Hi everyone, I welcome you all to the 15th video of Module 5, and here it's time to test our model. Over here, first of all, we'll be generating the testing data using the same environment, and then we are going to compare this true output versus the predicted output, and then generate a mean squared error out of it to evaluate the overall model performance on this test data set. And finally, we'll be visualizing the test results using the scatter plot. So let's get started with this video. So after seeing that the training had happened pretty much smoothly, now it's time to put it on the test that the final values of this W and B, if they are really the optimal values, it should perform well on the unseen dataset as well. And that unseen dataset is nothing but the test dataset. I hope you remember this when I was discussing about the training dataset. I had also mentioned about the testing dataset. This is where we actually put your model into the test and see that based on the model weights and biases that got trained, if it has achieved this optimal value, the prediction over here that you will be getting will be very much closer to this Y test. And then we have some of the matrix to check if it's really close or not. For example, in the regression, one of the metric that we use is the root mean squared error. So we're going to find out how much close your prediction values are with respect to your Y test, original Y test values. Now, one thing you need to keep in mind over here is that while generating your test data, it should be generated in pretty much the same way like we had generated our X-train data. Because you remember, I had also mentioned about this point that you always have your test data from the same environment that you have used for the training part. Alright? So I cannot have, let's say for example, in your test, I give you the algebra of 10th grade. But in the training process while I was teaching you, I teach you the algebra of 8th grade. So if I take this kind of environments, like, I ask you the questions from this 10th grade, you won't be able to answer it. And therefore, having the same environment is compulsory. Now in the test data, I'm having 10 rows and it is generated in the same way. But note that the seed value is different. There is a specific purpose behind that. If I choose the seed value of 100, that's a big blunder because it's going to give me the first 10 same values as I was having in my training data. And therefore, to avoid that same kind of values in my test as my training data, I am using some different value of the seed value over here. And then to generate the true values with respect to the input, I am using that exact same formula, that is 2 times, that is the bias times your X value plus the, I should say weight times the X value plus the bias plus the noise. It's the same exact equation that we had used for your Y train. And now after this, we are going to make a comparison of this with this prediction. Now, what is this prediction? This prediction is, we have calculated this with the help of that predict function that we had created during our forward propagation. And now, instead of passing X train, I am passing X test. And then instead of passing my weight and B value as 0, 0, I am now passing it to be the final value of the weights and bias that I had got after the training was completed. So it's basically the last value for the respective list. And these values are nothing but the ones that we had seen in this particular table. So I'm using this value for the weight and the bias in my prediction. And now, once this kind of prediction is calculated, I'm again creating this kind of a tabular output with the help of pandas data frame, where I'm again zipping this kind of 3 things because I want 3 different columns now. One for the original X test value, then the Y test value, and lastly the prediction value to compare this original output with. And now I'm also reshaping it into a one-dimensional output from that row into column. I'm just converting that into one-dimensional output so that it is actually matching the requirements of this pandas data frame. And after that, I'm also giving the names for the column, that is test input, true output, and therefore the last one to have the comparison, I am also having the predicted output over here. And then finally displaying this kind of the data frame, I can simply go ahead and run this particular part of code. And you can see that this is the type of output that we have achieved. If this was the brightness of the star, this was the star size. And this is what your model has predicted. 10.97. Isn't it so close? After that, if the test input, that is the brightness of a star was this was the actual star size. And this is what your model has predicted. So close. Just look into this. Like this, you are having 10 set of inputs. These are the respective true values, and just compare it. How close we have got to this true outputs. it means your training was pretty much successful, right? So yes, this is what I demonstrated over here, that even if you are not having the actual values of this 9 and 2, you can still get this kind of a sense of how much good amount of predictions you have achieved. Now, if you want to compare this mathematically, not visually like this with human eyes, then you can go ahead and try to check some of the metric like mean squared error or maybe root mean squared error. I could have also used RMSE over here instead of MSE. But now that I have written a comment over here to use a mean squared error, let's go with that. So I'll just say that MSE is equal to np.mean of the, what is the y test minus, what is the thing that I need to subtract it with, y test minus prediction, and then I need to square it up, right? And then I need to take a mean of that, so I'll have a bracket over here as well, and this is going to give me MSE value, right? I can just print this correct to, let's say for example 5 decimal places. So I'll say that the MSE for the test data is this MSE value, and I'll round it up correct to 5 decimal places. I'll say that this is rounded up to 5 dp, and hopefully everything is working fine. I'll just run this code. You can see that the mean squared error for the test data is this after rounding up to 5 decimal places. Now let's see if I want to have square root on top of this to calculate the RMSE. I'll just pass np.sqrt for the square root on top of that mean data, right? This is your RMSE, and you can see that this is the output of the RMSE. You can go with any of the matrix that is useful for your use case. I'll be simply sticking with the mean squared error, okay, not root mean squared error. So yes guys, this is the output that we have achieved over here. Now, after this, we are going to simply go ahead and visualize the performance on this test data. Again, we are going to have this figure size, and then the plot is with respect to the x test and the prediction, and x test with the y test, and then we are going to customize the output. So let's go ahead and do this. So plt.figure with fig size, that is 10,4, that's fitting best in my screen, and then plt.plot, what kind of plot I want x test with the prediction, and then I also want plot of x test with the y test values. And then I can also label this line as that this line is for the actual true outputs, and over here I can say that label is equal to predicted outputs, and later on I can also turn on the legends. This legends is going to ensure that this kind of label is displayed on the graph. And let me just have plt.show to see how it's going to look like. Okay, it says that okay, I need to use legend over here, not legends. So this is the type of output. Well, this true outputs over here is seeming a bit weird. The reason behind that is these are the scatter plots, not a line plot. So for that, I'll just have to change this to scatter to show that just the individual plots on the curve. And this is how it's going to look like. Let me just go ahead and change the marker of this to X. And I'll also add a color of this to red, for example. And let's see how the output looks like now. This is looking much better, right? This is looking indeed much better. Now, for sure, I can go ahead and add a lot of more customizations as well in order to make it look even more beautiful. All right. It's completely up to you how much more changes you want to have over here. And it's fine according to the way that it suits you the best. But for me, let's say I'll just add some few more details over here. You can clearly see that this is the predicted line by your model. And this blue is the true values that you have in the y test. It's predicting so well, so well. And I'll just have a little bit more customizations over here. With respect to that scatter plot, I'll simply go ahead and have Z order also. Z order is equal to 2, which simply is going to bring the crosses on top of the line. Initially, this was not the output. These crosses were below this line. So I've just brought that order of that plot a bit upward so that line is below that. And I'll also decrease the line width that I'm having over here. And let's say I'm having 0.7 for the line width. And this is looking just fantastic. Okay, if I want, I can also have a line style is equal to dashed. Hopefully this is the command that we give. Yes, it is indeed that command. And that's how it's going to look like. It's not looking, to be honest, anyway good. I'll just delete that part. And maybe I can decrease or increase this marker size if I like. Let's say, for example, I'm choosing a marker size of 20 over here. I need to give S parameter. Let me give it as 20 and see how it looks like. The smaller ones are looking much better, right? This is looking much more neat. Now, after this, I can simply go ahead and give some X labels, Y labels, and I can customize them as well and also give a title to it. And that's it. That will be the end of this particular part. So plt.x label. What is the X label over here for me? It's the test inputs, let's say. Test brightness. BRIGHTNESS. And then plt.y label is, let's say, a test. I'll just call it as size of stars. Test brightness of stars. Right? And then color, let's say I'm having this time maroon over here. And over here also color is set to maroon. And maybe font size, I'm not going to change it this time. I'll just keep it as it is. plt.title. I'll just say that visualizing the performance on the test data. Visualizing the performance on the test data. You can keep this T capital if I like. And then I'll give this color, let's say, because maroon I have used for the labels of X and Y. Let me choose a color over here as I'll go with royal blue. Royal blue. And maybe weight is set to bold. Let's see how it's going to look like now. Oh my goodness, this is looking just great. I just changed this red color to maybe black so that it's going to look a bit better than this, I hope. Yes, of course, this is looking much better. So yes, I am now satisfied with this. If I want, maybe I can also change this kind of legend position to maybe, let's say, for example, lower right in this particular part. So for this, I just need to pass in one argument inside this legend. That is, the location is going to be lower right. And you can see that the location of the legend is indeed shifted over here. I can also play around with the font size over here and do a lot more things over here. But I'll just leave it as it is. And I guess, yes, we are done for this particular notebook, guys. Now you can surely go ahead and download this notebook and save it into your system. So I'll just go over here, click on download and download the IPYNB file, and I am all set. So yes guys, that's it about this particular video, and at the same time this was your first machine learning algorithm that you have created by yourself from scratch.